There really isn't that much to teach as far as factoring, but I just want to remind you of a few things. Like if I'm factoring this, how do you factor something like that? I mean, what do you do? No. Yeah, just quadratic. So it'll be W is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And you could factor that, right? And you'll get 16 minus, let's see, 32, 64, 128, 256. 16 minus 256 will be very negative. You'll have your I, won't you? And so the way that the reason that we're doing complex numbers is sometimes this is going to be complex. And you can do that factoring with the quadratic. That's old news. But I still want to bring it up because you'll use it. This one's kind of interesting. Z cubed minus this. I was wondering if you could take out a z squared in this one. That's 5. I'll let you think about that one. And then these are the ones that I wanted to focus on. Find all the complex numbers z such that z to the 4th minus z cubed, etc., equals 0. Z equal to 1 plus 2i is a solution to the equation. So here's an example of IB question. This is right off an IB exam, and you're going to learn how to do these. First things first. Let's say we had z equal to 4. Is that a root or a factor? 4. That's a root. But if we went z minus 4 and set it equal to 0, now what is z minus 4? A factor. Okay? You think I'm doing old stuff. I am, but watch this. Z, they said, equals 1 plus 2i. Turn to your neighbor. Is that a root or a factor, and why? What is it? It's a root. It's a root. It's still a root. So to make it a factor, you set it equal to 0. You go z minus 1 minus 2i equals 0. Now it's a factor. Do you see that? That's the most important thing of this whole lesson today. And I'm going to do this problem quite quickly. You're going to say that all roots come in pairs. So you have z equal to 1 plus 2i, z equal to 1 minus 2i. But look at what happens when you look at the factor. You're still going to have z minus 1, but then it'll be plus 2i. Do you see these two factors? Okay, this is guaranteed to happen, that you're going to have this conjugate pair. Every time, they always come in pairs. Remember quadratic formula, plus or minus? Yeah, that's where you get it. So what you're going to do to solve this is you're going to multiply these two factors. And I'm just going to do it this way. Z squared minus z plus, this is a 2, 2zi. Is that part all right? Next, I'm going to multiply these three together. And this is going to be negative z plus 1 minus 2i. Then I'm going to do one more. I'm going to multiply these three together. Negative 2iz plus 2i minus 4i squared. And when I add all these up, these guys are going to cancel. These guys are going to cancel. And what just happened there to all my i's? They're gouged out, right? Oh, I shouldn't say that. What's I squared equal to again? -1. So this is going to be z squared minus how many z's? 2z. And then it's going to be 1 plus what? 4. And that is the product of the two factors of z. Not the two roots, but the two factors of z. Then all you have to do, going up to this spot, is you say, okay, z squared minus 2z plus 5 times what is equal to z to the 4th minus z cubed plus z 6z squared plus 15. And then what you do with that is you got to figure out z squared times what is z to the 4th? Z squared. And 5 times what is 15? Plus 3. And I think that will get you all the middle terms. And so z squared plus 3 equals 0. You're going to get z equal to plus or minus 3i. Finish those factors for Monday and that salmon sheet. Have a good weekend.